Hello, my name is Boraji Diallo. This is a presentation about mobile cloud computing, offloading computation. As we all know, mobile devices have become part of our daily life. Users want to gain access to their applications such as social media, business, and games while on the go, regardless of where they are. However, mobile devices have limited resources such as battery life, storage capacity, and performance. This restriction may be alleviated by using mobile cloud computing, which integrate cloud computing into the mobile environment. The goal of this presentation is to give readers an overview of mobile cloud computing and discuss some of the challenges related to offloading computation. The first term we're going to discuss is cloud computing, which is basically a framework which enables user to access computing resources on demand. There are three cloud delivery models as shown below. The first is software as a service. This is software distribution model in which a third-party provider hosts application and make them available to customer over the internet. The second is platform as a service. This is a cloud computing model in which a third-party provider delivers hardware and software tools, usually those needed for application development. Lastly is infrastructures as a service, which is a form of cloud computing that provides virtualized computing resources over the internet. This leads us to mobile cloud computing. Basically, mobile cloud computing is made out of three general parts as shown below. The first is mobile devices, followed by wireless communication means, and computational cloud infrastructures, which contains data center. So the general idea of mobile cloud computing is moving the computing power and the data storage away from the mobile devices and into the cloud. Lastly, the last thing we're going to talk about here is computation offloading. Computation offloading basically minimizes execution time and resources used when running resource-intensive application on a mobile device. The environment supporting computation offloading is visualized in the figure below. In this illustration, method B is offloaded to a cloud server or other similar powerful machine. The cloud in this diagram may be a server, a cluster in a computing center, a computing grid, or a virtualized cloud server. Several approaches exist which focuses on improvement of mobile device capabilities such as saving energy, response time reduction, and execution cost minimization. For examples, Malmos, which is a machine learning based mobile offloading, take previous process offloading decision and their correctness into account to dynamically adapt scheduling decision to enhance user experience. Additionally, Mosaic, which is a mobile cloud service composition, take mobility and resource constraints into account. Each of these frameworks here have their advantage and disadvantage. So the frameworks above were compared based on four factors: security, fault tolerance, latency, and energy efficiency. Security is one of the main concerns in computation offloading. User data is put at risk of data breach and personal information invasion. Therefore, it is crucial to have better security mechanism in place for users to feel more safe using their applications. In mobile cloud computing, mobility is an essential attribute. This said, some constraints can prevent seamless connectivity between a mobile device and the cloud, especially while actively moving. Network issue can cause offloaded computation to execute for a longer time compared to a local execution. Furthermore, latency is the amount of time taken to offload a computation, process it on a cloud server, then return the result to the mobile device. Latency directly impacts user experience and must be handled by the application and cloud developer. Lastly, mobile devices are relatively limited by battery capacity compared to stationary devices with stronger and long-lasting energy sources. It is therefore important that the energy and the resources required for offloading a computation is less than or equal to that needed to run the same computation locally. The main takeaway from doing this presentation is that none of the above framework provide a strong security method to provide privacy and offloaded data security, as mobile devices lack the processing power to do so. If I had the time, I will extend the project by doing more research on ways for developing less computationally and resource intensive security measures. And these are some of the references I use to get this service going. And if you need more information or want to know more about mobile cloud computing or just need more info in general, please refer to the survey attached. Thank you for listening and thank you for your time and have a great rest of your day.